Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is a cyclopentanone with two substituents at C2, a carboxylic acid, COO group, and a tertiary alcohol group C, or CH3I, a 1-hydroxy-1-methyl group attached at C2 of the ring. Moving on to the next step. Reaction with KBrOH+, oxidative conditions, haloform type or oxidative decarboxylation KBrO under acidic conditions with heat acts as an oxidant. The tertiary alcohol C, or CH3, adjacent to the carbonyl is oxidized. More specifically, KBrO, analogous to hypohalite, under these conditions performs an oxidative cleavage of the alpha-hydroxy ketone or effects a haloform type reaction on the methyl ketone side. The C, or CH3, group, which is effectively a tertiary alcohol with a methyl, undergoes oxidation. The C-to-C bond between the ring carbon and the C, or CH3, group cleaves oxidatively, removing the C, or CH3, fragment. This gives intermediate, X, which retains the COO group at C2 of cyclopentanone, i.e., 2-carboxycyclopentane 1-1. Moving on to the next step. Compound X is 2-carboxycyclopentane 1-1, a beta-keto acid, since the COO at C2 is beta to the ring carbonyl at C1. Beta-keto acids readily undergo decarboxylation upon heating, loss of COO2. Heating X causes loss of COO2, giving cyclopentane 1-1, cyclopentanone, as product Y. And for the final step, A still retains the hydroxymethyl group. This would be the product if only the COO were removed without oxidation of the alcohol. B is intermediate, X, not the final product. Y, D, methylcyclopentane has no ketone and would require reduction, not consistent with these conditions. Therefore, the correct answer is C. Therefore, the correct answer is option C.